Okay, in this, continuing on, we're going to explore the idea of defining classes with a case of a class that represents a shelter animal up for adoption. And we're going to use a library that's in the Python standard library for generating unique identifiers. And that's just kind of for illustration purposes. So I'm defining this class, shelter animal. It inherits from object, and I define a constructor. And with this constructor, I provide myself argument, and then a number of keyword arguments such as the species, which we're going to say is a dog, that we need to provide a name, could be none, age is an integer, and then the shelter ID. And just as we did with the previous example, we're going to use these properties so we can do a little bit of checking. So the first thing I'm going to, when I go to set the name, I'm going to make sure that it's a string. Similarly, that a species must be a string. An age must be a real number that's greater than or equal to 0. And I'm calling all these getter and setter functions through the properties in the constructor. And the only thing that I'm kind of doing a little bit interesting here is I check to see if they didn't provide an ID because it still has the default value of none. Then I go and I generate a unique identifier with this UUID method, and I return it as an integer and use that as my shelter ID. In addition to having these property getters and setters, I defined a method greetings. And so this is just a method that I can call so that our animal can introduce itself to its potential adopters. And so it's just a string that's going to tell the person a little bit about themselves. So I'm going to, hi, my name is, and I'm going to insert the name for this instance, the age, the species, and the ID. And you can see we're using the same dot method that we've used throughout the class. We have an instance of our class, self, and I want to get at its age attribute, so dot age, dot species, etc. So if we run this, then we can create an animal that we're just calling here dog. So we provide the name Argos and provide the age of 3. So everything else will just be the default attributes that we define in our constructor. So it'll be a species will be a dog. And since we're not providing a shelter ID, we'll generate a unique one with the UUID method. So here's my dog, and then I can call the method with this dot greetings. And again, greetings is a function. It has the single argument of self, which we do not provide. Python provides that self argument implicitly. So hi, my name is Argos, and I'm a 3-month-old dog. My ID is this absurdly long identification number. We can do the same thing with another dog, Helios. And we have our families, 2 dogs now represented with these Python classes. Well, if I'm representing an animal in a shelter, there's probably more that I want to know about that dog than what we've provided here. And so, particularly since we have a dog that doesn't like other dogs, we're aware that pets have problems. And so what I'm going to do here is we're going to change our class so that we have an attribute that's problems, and we'll just use a list, and we'll create a method that we're going to call adoption match, and we're going to pass in a bunch of features which would be problems in quotes. So it might be that this family has kids, this family has a cat, this family has other dogs. And we're going to say the adoption match is true if there's nothing on the feature list of the adopters in the problem list for the adoptee. And I've changed this class definition so we're not actually using a class variable in this example. So here's my recoding of that example. So I have the constructor. I don't change what arguments are coming into it, but I am going to create this empty list problems. And so then I need methods to interact with that. So I have this add problem where I would pass some problem, which I'm going to just assume is something like a string, and append it to my problem list. Now I'm kind of doing this implicit typing because I take problem and I try to convert it to a lower string. And this is an example of what's called duck typing. So a lot of people don't like doing this is instance checking because you could have an inherited class that's not a string but acts like a string. So this is called duck typing. If it looks like a duck and it quacks like a duck, we can just treat it like a duck. So I'm not explicitly doing any type checking, but I treat it as if it were a string, and if it doesn't let me do a string-like thing to it, this will raise an exception. Okay, and then I have my adoption match where I'm going to, again, pass in a list of features, and I'm going to check, again, assuming that these features are strings, see if that's in my list of problems, and if it is, I'm going to return false. This isn't a match for adoption. And if I go through my entire set of features and there's no match to the problems, then I'll return a true that yes, this is a potential match for adoption. So let's go through here. So I'm going to create my Argos and Helios shelter animals, and I'm going to say that Helios has problems with dogs and cats, and then for a potential match, the family that wants to adopt this dog says, well, they have birds and they have kids. And so those features of the adopters get run against my list of problems, and it's aha, this adoption match this is an adoption match because Argos doesn't have problems either with birds or with kids. Now, what if I get a different family and they have dogs and they have kids? Well, now as I run through this, now this method of the class that I've defined returns false because dogs are going to be checked against dogs in my problem list and return false here in my method call. Okay, and as we illustrated before, I can add an attribute to an instance of a class, but that doesn't promulgate through other instances of the class. Okay, so a couple of things to think about here. So I had already defined a shelter animal class, and we went ahead and just replicated and rewrote all our code again to add our problems and to add adding problems and doing an adoption match. This would have been a great example of I could have used inheritance to add attributes, and we'll do that in the next notebook when we go over a person. The other thing to think about is how we represent age. And so age is just a number. So how do we make the animal get older? As you know, they sit in that shelter all the time. I have to continually update my age. So is there a better way of representing the age of an animal? So something for you to just think about there as I fix my typo.